This video will give you a good overview of the X-Audit module of X-Analysis. X-Audit can be added on to the base XA Professional module and provide you with insight into the size and complexity of your applications. Let's dive right into the tool. So I'm going to open up my repository here, and I can access the metrics dashboard in a couple of different ways. I can either click on metrics dashboard here in my navigation window and have some buttons to use. I can also right click on the repository and scroll down to audit options and have a right click type of menu to access it. And we'll start with the metrics analysis. So the metrics analysis gives us an idea of the size and complexity of our application in terms of lines of code and in terms of a couple of different industry standard complexity calculations which are performed. What we see here is at the top a general overview of our application in terms of the quantity and complexity of our code. I can see that in my application I have 128 programs, and those programs are broken down into interactive and batch. So I can see I have 50 interactive programs and 78 batch programs. And those programs have been classified or bucketed into different levels of complexity. So within my interactive, I can see I have one high complexity program, 17 average complexity programs, and 32 low complexity programs. And we'll talk in just a minute about how X-Analysis determines and buckets these programs into different complexities. For each individual program in my environment, we'll look at the average complexity programs here. X-Analysis tracks a variety of different pieces of metrics information. First of all, I have lines of source code. I also have my complexity calculations, so calculated by the cyclomatic method and also by the Halstead method. And we also keep track of certain information from the programs which might help us determine the complexity of a program. So, for example, how many files does that program use? How many programs call it? How many programs does it call? And so on. Now, I mentioned that X-Analysis allows you to define how these programs are slotted into the different complexity buckets. And that's done by using this table. Click up here in the toolbar for General Metrics Preferences. X-Analysis allows you to specify the thresholds for each of the different complexity metrics that we maintain in order to determine how those programs are slotted into the different buckets. So for example, I have mine set here to fairly simplistically. I'm just saying that if a program has more than 800 lines of code, it's going to be considered high complexity. If it has between 200 and 800 lines of code, it's going to be considered average complexity. And if it has less than 200, it's going to be considered low complexity. So you can play with the different metrics and set different thresholds within each to change the way that X-Analysis slots these programs into either the high, average, or low complexity buckets so that it makes sense for the way that you would evaluate complexity within your organization. So often this is used by our customers, particularly in large environments, with numerous developers to kind of give them a sanity check and make sure that they are assigning the higher complexity work, higher complexity programs and changes to the more senior experienced developers, and the lower complexity programs to more junior developers or perhaps some outsourcers who are new to the organization. X-Audit also gives us the ability to track the size and complexity of our applications over time. So if I double click on my average programs here, what I'm able to see is how the size and complexity of my application has changed over the period of time that it's been tracked in X-Analysis. So I can see that this particular application has been I've been tracking it in X-Analysis for over 5 years now. And I can see how over the course of that period of time, the number of lines of source code have either increased or decreased right up till the current state. Same is true for complexity as well. So this is really handy for being able to monitor if your application is becoming overly complex, if your application is becoming overly large, how a particular event such as outsourcing the application support of this application to a third party has impacted it in terms of complexity or lines of code, and perhaps monitor the quality of some of the application support services you're getting. It can also be used to measure and quantify the success of code simplification projects. So a number of our customers have launched projects to simplify their code as much as possible. For example, taking routines which are repeated in multiple programs, centralizing them into a callable module, and therefore reducing the amount of code in the application. So the success of a project like that can be evaluated by seeing how much you've managed to reduce the number of lines of code, and as a result, the complexity of your application during the time from the beginning of the project to the end of the project. X-Audit also gives you the ability to track the change history of a particular program, right down to what was done for a particular, as part of a particular change to the program. So I can see here that 20 months ago, in March of 2013, this WWCUS program was modified. By right-clicking on the program, I can actually compare the before and after version of the program from that change side by side in a window to be able to see visually what was the change that was made. I can see there's a couple of F-specs here that have been changed to add prefix keywords and so on. So very handy if you're investigating a problem that is traced back to a particular change. You want to know exactly what was done in that change. X-Audit can help you find that information very easily. Now, all of the functions that I've described here can also be applied to application areas. What we've been looking at up here is the application as a whole, but all of these metrics are also available by application area. So if you want to track size and complexity of a particular area of your application, you've broken that out using X-Analysis to split those out into functional areas, perhaps using application areas. All of your metrics and complexity analysis can be executed on an application area as well as to the system as a whole. Something else that's provided by X-Audit is the automatic generation of a problem analysis. The problem analysis is an automated way, every time your repository is regenerated or refreshed, of finding certain inconsistencies, problems that may exist in your application environment that would otherwise be very, very difficult to identify unless they actually manifested themselves as a problem in production. So here we're talking about things such as source and object inconsistencies, source code which does not have an associated compiled object, compiled objects which doesn't have an associated source code, programs which are referencing database files or data areas, or calling programs which don't exist in the environment, copy statements which don't have an associated copybook member. So these are the type of inconsistencies that with a manual analysis would be very difficult to find. X-Analysis checks for them in an automated fashion and updates this list every time that you do regenerate or refresh your repository. So a very handy thing to check out on a monthly or bi-monthly basis, just to see if anything has changed, some sort of new error condition or inconsistency has been created, and giving you the opportunity to check that out and perhaps correct it before it causes a production problem. X-Audit also does some program code checks, so we call it program code or program quality alerts. The classic example of that is identification of go-tos in the program code. Many of our customers have implemented policies of not introducing any new go-tos into the code, as coding in a more structured manner. And this enables them to keep tabs on whether new go-tos have been introduced into the code since the last time they checked. So if I open that up, I can see which programs actually have go-tos in them. And if I want to drill in, and I can just double click on that and it'll take me right into the program code at the line where the go-to exists. So very easily to identify, and if you wish, go in and perhaps change that to use a more structured programming method. There's also some identification if you happen to be thinking about or in the process of doing a conversion of your DB2 files into more of a DDL definition language using SQL tables. The problem analysis also highlights potential DDL conversion issues. So things in your current file system which might cause problems if you were going to convert your DDS to DDL for generating SQL tables. And this would be things like physical files with a non-unique key, files with no members or files with multiple members, files that are internally described, and so on. So this is just an easy way of identifying up front what those issues might be before you actually embark on the project and run into those mid-project. We looked at program metrics earlier. X-Analysis can also provide similar type of information for both your screens and your files. We'll touch on that just very briefly here. The layout is very, very similar to what we saw with the programs, although the metrics that are tracked are different depending on the type of objects that you might be tracking. So in this case, we're looking at screen metrics, and here we track and identify things such as the number of files that are accessed from a particular screen, the number of fields that are used both from the database and work fields, calls both incoming and outgoing that particular screen does, number of function keys used, and so on. So again, just a very easy automated way to be able to, kind of figure out what's the complexity of a particular screen or interactive program. Likewise, for database files, we can look at a file metrics display. So here we're able to see things such as the number of fields in the file, the number of access paths built on a file, how many programs are out there that create that file, that read it, that update it, that delete from it, and so on. So where are all those references, and how many are there? X-Audit also provides what we call a specialized analysis. And the specialized analysis is really just a way to allow you to execute some predefined reports, metrics analysis reports, which have proven to be useful to some of our customers in the past, but also to define some of your own reports as well. So if there's a report which is not provided within the X-Analysis tool, you can actually use the report design tool by clicking up here in the toolbar, create new report, and there's a very easy to use wizard which allows you to select from some of the metrics fields and complexity based fields that are tracked by X-Analysis to build your own report. And again, some reports that have proved useful to our customers have already been included with the tool. Some source object reports to identify missing sources or objects, different inconsistencies like that, and then some metrics-based reports as well. X-Audit also provides the ability to compare two different repositories that are within your X-Analysis environment. This can be very useful if you are perhaps using a packaged application for which you own the source, and the vendor has provided you with a new version of the application. You need to identify the changes that have been made since the last version that you installed, as well as identify the changes that you've made to your application, which perhaps need to be reapplied before you can upgrade to the vendor's new version. This is done through the use of the inter-repository options, and using the inter-repository options, you can generate a difference analysis. And when you generate the difference analysis, you're simply comparing an existing repository with another existing repository and asking it to generate the differences that it finds between the two. So in the example that I just gave, you would create a repository for your current production version of your application and another repository for the new version delivered to you by the vendor, and then generate a difference analysis between those two repositories. The result of that difference analysis tells you what programs, commands, files, modules, and so on have been changed or added in the new version you received. This information will help you evaluate the complexity and potential effort required to actually update or reapply the changes to the new version of the application in order to take advantage of the new version provided to you by the vendor. As you can see, for a particular file or a particular program, we can drill down and see exactly what the difference was that X-Analysis has found between the two versions. For example, let's look at the differences for a particular RPG program within the application. We'll open up CustMNT1, and what can we see? Well, we can see that there's a reference or a call to another program, CustP, which has been deleted from the program. We can see how the number of source code lines have changed from one version to the next. We can also identify different subroutines which have been either added or removed from the program. And finally, we can also see where different business rules have been added or removed from that particular program. This functionality, it ties into the X-Analysis X-Rules or business rules identification and extraction module. And that provides a high-level overview of some of the many features of the X-Audit module of X-Analysis. In conclusion, X-Analysis enables managers of legacy applications to measure, monitor, and proactively manage the complexity and changes to their applications.